To simplify these two non-perfect square roots, which when you type these two in your calculator, it will give you a bunch of decimals. So we want to simplify these two into even smaller square roots. And how do we do that? Well, if you know your perfect square roots, such as 1 squared is 1, so therefore 1 is a perfect square root. 2 squared is 4, so we know that square root of 4 is going to be 2. 3 squared is 9, so we know 9 is going to be a perfect square root. And 4 squared is 16, so we know that square root of 16 will be 4. Do last one, 5 squared is 25, so I know that square root of 25 is going to be 5. So we can simplify these two non-perfect square roots using our perfect square roots. So for 72, I know I can just use the square root of 4. So because I know that square root of 4 times square root of 18 will give me square root of 72. And now I can simplify square root of 4, and that'll give me 2 and bring down the square root of 18. And I can see I can break down 18 even more because I know the perfect square root of 9. I know 9 times 2 is 18. So therefore, I can rewrite this as 2 times square root of 9 times square root of 2. And we know what square root of 9 is. That's 3. So now I'm going to multiply 2 times 3. So that will give me 6. And you bring down the square root of 2. And that's the simplified version for square root of 72. And we can do the same thing with square root of 200. So again, I can use the perfect square root of 4 because I know that square root of 4 times square root of 50, 4 times 50 is 200. And again, square root of 4 we know is 2, and you bring down the square root of 50. So again, I can break down square root of 50 because I know that 25 times 2 is 50. So I can rewrite this as 2 times square root of 25 times square root of 2. And we know what square root of 25 is. That's 5. And again, we can multiply 2 times 5, which is 10, and bring down the square root 2. And that's the simplified version for this non-perfect square root.